Hello, welcome back. Today we're going to be solving quadratic equations using square roots. The objective is that by the end of this video you should be able to solve an equation that looks like this. To get us started, I've got a key question. What are the solutions to x squared equal to 4? How do you get x by itself in the equation x squared equals 4? And when you take a square root, how many solutions should you get? Now all these have different answers, but they're all part of the same general idea, which we're going to look into as we work through them. First one, what are the solutions to x squared equals 4? In other words, what numbers can I substitute in for x and square them to get 4? Well, the obvious solution is 2. Why? Because 2 squared equals 4 is a solution, because 4 equals 4. Now the not so obvious solution is x is also equal to negative 2. Why, you might ask? Because negative 2 in parentheses squared, negative 2 times negative 2 is equal to 4. So 4 equals 4. Notice, when you square positive 2 you get 4, and when you square negative 2 you get 4. So the solutions to x squared equals 4 are x equals positive 2 and x equal to negative 2. So the next question really is about the solving process. How would you get x by itself in the equation x squared equals 4? Notice x is not by itself because there is an exponent of 2 attached to the x. So think to yourself, what is the opposite operation of squaring something? The answer is you can get rid of a square by taking the square root of both sides. Notice the square root and the square will cancel each other out, giving us x is equal to the square root of 4, which means x is equal to 2. But you should notice right away, if we solved this equation using a square root, which brings us back to our objective today, you end up with only one solution. Now the reason this isn't completely correct is because when I take the square root of both sides of an equation, one of which being x squared, I end up with a positive and a negative answer, which we can list as plus minus 2. So again, if I'm going to solve x squared equal to 9, I would get the square by itself by taking the square root of both sides, and my solution would be x is equal to plus or minus the square root of 9. Or x is equal to plus or minus 3. The plus minus means there is a positive solution and a negative solution. So that brings us to our last question, last key question. When you take a square root, how many solutions do you get? The general answer is you should get 2. 1 plus and 1 minus. So to summarize in writing, when you take a square root of a variable or variable expression to the second power, you get a positive and a negative answer. Another key question is, what are the solutions to x squared equal to negative 4? Now this one's just slightly different from the previous equation. But in what way? In the previous equation we solved, we got x squared equal to positive 4, and we found out there were 2 solutions. For this one, you're trying to find the values of x that will make x squared, or the number squared, equal to negative 4. So what number can you square to equal negative 4? The answer, there is no number. Because when we square any number, or any real number rather, we'll end up with a positive answer. So there's no real, let me insert that word, solution. You could also see that by trying to take the square root of both sides. And the square root of negative 4, if you try to take that in your calculator, you would most likely get an error message saying non-real answer. So to summarize, if a squared is equal to a negative number, if an x squared is equal to a negative number, there are no real solutions. Also, we cannot yet take the square root of a negative number. Notice the word yet. That's to indicate that there will be a time in the future where you'll be able to take the square root of a negative number, but the solution will look different than what we're used to. So this all brings us to our objective of today, which is to solve an equation, or a quadratic equation, using square roots. The way we're going to solve using square roots is we're going to solve our equations in the reverse order of operations, or in SADMAP order. I went ahead and wrote down what the S, the A, the D, the M, E, the P stand for, and we're going to go ahead and work an example here in a second. So we're going to solve the following equation by undoing operations in SADMAP order. First thing you want to do, since we're going to try to get x by itself, draw a line down through your equal sign to indicate the left and right hand sides of the equation. Then go ahead and box your x value. That lets you know that you're trying to get the x by itself. Then we're going to take a look at SADMAP. Our first step, or first operation to undo, is subtraction or addition. So we go over here to the side with the x, and we see if there's any subtraction or addition we can undo, and we see that there's a minus 5. So we can do that by adding 5 to both sides of our equation. The negative 5 and 5 cancel, giving us 2x squared is equal to 13 plus 5 is 18. We can now get 2x squared by itself. Again, I'm going to keep the x box, by going on to the next two operations, division and multiplication. Is there any division or multiplication on the side with the x squared that we can get rid of? The answer is yes. We can get rid of this 2 times x squared by dividing both sides of the equation by 2. So 2 over 2 gives us 1x squared, or just x squared, equal to 18 over 2 is 9. Now we go on to our last step, in our case, which is exponents. Can we undo the exponent of 2? The answer is yes. We can take the square root of both sides. Remember, when you take the square root, you get x is equal to plus or minus the square root of 9, which means your answer is equal to x, or rather is x equal to plus or minus 3. Now you can split that apart if you want to make more sense of it, to show you that x is equal to positive 3 and x is equal to negative 3 are two different solutions for our equation. As is usual, it's a good idea to check your solutions when solving. So if I go to my equation and I take the value of 3, substitute in for x, I should get a true statement. When evaluating an expression, you must go in PEMDAS order. So we solve in SADMAP, but we evaluate in PEMDAS. So we square the 3 first, giving us 2 times 9 minus 5 equal to 13. 2 times 9 is 18 minus 5. And 18 minus 5 is 13 equal to 13. That shows us that positive 3 does indeed check out. We can check out our negative 3 as well by substituting in negative 3 for our x value, giving us 2 times negative 3 squared minus 5 is equal to 13. Negative 3 squared is 9. We get 2 times 9 minus 5. 2 times 9 is 18. 18 minus 5 is 13 equal to 13, and we find out that negative 3 checks out as well, because when we substitute it in for x, it gives a true statement. Now we're going to solve a bit more of a complex problem using our SADMAP order, or by undoing operations. And taking a look at this problem, first I'm going to split the equation into 2 different sides. I'm going to go ahead and box my x to let myself know what I need to get by itself. And then I'm going to see if there's any subtraction or addition I can undo. You'll notice it looks like there's 2 different subtractions and additions that we can undo. There's a plus 7 and a minus 5. We can only undo the plus 7 first, because the minus 5 is trapped inside of these parentheses, and you'll notice parentheses comes as the last step. So let's undo that plus 7 by subtracting 7 from both sides, giving us 2/3 x minus 5 is going to be equal to 13 minus 7, which is 6. Now we're left with a 2/3 x minus 5. So we look back at our problem and we see if there's any division or multiplication we can undo. we can undo 2/3 times x minus 5 by multiplying both sides of our equation by the reciprocal, 3 over 2. I'm going to go ahead and do that in a different color. When we do that, the 3 over 2 and the 2 over 3 cancel out, or just give you 1, leaving you with just x minus 5 squared is equal to, you have to put the 6 over 1, multiply tops to tops and bottoms to bottoms. So it's equal to 18 over 2. That's an 8, by the way. So x minus 5 squared is going to equal to 18 over 2, which is 9. We can then see if we can get rid of that exponent, which we can by taking the square root of both sides. Remember, it gives us a positive and negative answer. So x minus 5, by the way, the square root and the square will cancel, again giving us x minus 5 is equal to plus or minus the square root of 9, or 3. We're going to then add 5 to both sides, giving us x is equal to, now you can't combine a 5 with a plus minus 3 yet. What we're going to do is we're going to write 5 plus minus 3. And then as our final step, or second to final step, we're going to split this up into two different solutions. X is equal to 5 plus 3, and x is equal to 5 minus 3. So our two final solutions, 5 plus 3 is 8. I'm going to write that up here. And x is equal to 5 minus 3, or 2. Now you can go ahead and check out those solutions on your own by substituting them in for x, and then solving out the left-hand side of the equation to make sure it equals 13. And this is the last variation of what we will see. In order to solve for x squared, we need to get x squared by itself, but you'll notice that there's x squared on both sides of the equation. So what we need to do is we need to get rid of one of the x squareds off of one of the sides of the equation. To do that, I'm going to look for the smallest of the x squareds, negative 3x squared or negative 4x squared. Since negative 4x squared is a lesser than number, I'm going to add 4x squared to both sides. You could have added 3x squared to both sides, that would have been fine. But I just choose to add 4x squared to both sides because it gives me a positive number in the end. Namely, x squared minus 7 is equal to 5, because negative 4x squared and positive 4x squared cancel. Add 7 to both sides, give me x squared is equal to 12. And then I'm going to take the square root of both sides. Give me x, because the square root and the square cancel, x is equal to plus or minus the square root of 12. And that's going to be our final solution. Since we cannot reduce the square root of 12 yet any further, we're going to leave it just like this. If you had a calculator, you could type in the square root of 12 to get a decimal approximation. I got 4 problems for you to try on your own to check your own understanding. Please pause the video, work through the examples, and press play when you're ready to see the answers. For the first example, we're trying to get y by itself, and you'll notice that the y is trapped inside the parentheses, which is enclosed, or rather created by the square. So we're going to get rid of that square by taking the square root of both sides, giving us plus or minus the square root of 3 is equal to 2y minus 5. We can then get rid of the minus 5 on both sides by adding 5. Now I can't combine a 5 with a plus minus square root of 3, so I'm going to go 5 plus or minus the square root of 3 is equal to 2y. To get the y by itself, I'm going to divide both sides by 2. And when I do that, I'm going to divide every term on both sides by 2. Give me 5 over 2 plus or minus square root of 3 over 2 is equal to y. And I'll actually let you leave your answer just like that in its exact form. For the second example, you should have subtracted 6 from both sides first, giving you negative 4/5 m squared is equal to negative 5. You then could have gotten rid of the negative 4/5 by multiplying both sides by the reciprocal, negative 5/4. So the reciprocal will cancel out with each other, giving you m squared, is equal to negative 5 over 1, gives us positive 25 over 4. We can then get rid of the m squared by taking the square root of both sides, giving us m is equal to plus or minus square root of 25 over 4. Now if you remember, the square root of a fraction is equal to the square root of the top over the square root of the bottom. So our final answer will be m is equal to plus or minus 5 over 2. Taking a look at this example, we need to get x by itself, so we're going to subtract 1 from both sides, giving us 22 is equal to negative 11x squared. Divide both sides by a negative 11, giving us negative 2 is equal to x squared. Taking the square root of both sides, giving us plus or minus square root of negative 2 is equal to x. Now if you remember, I told you we cannot take the square root of a negative number yet. So for right now, we're going to write no real solution. For our last example, we've got r squareds on both sides of the equation. In addition, you'll notice that not all the sides of the equations are simplified. So really what I'm always going to do first is I'm going to get all my r squareds on the same side after simplifying. So I've got a 7 and a plus 9, that gives me 16 minus r squared is equal to 2 minus 5r squared. Now I'm going to take the smaller of the two r squareds and get rid of that one. So since my negative 5r squared is less than negative r squared, I'm going to add 5r squared to both sides. You might have chose to add r squared to both sides. That's fine. You should end up with the same answer either way. This gives us 16. Negative r squared plus 5r squared is plus 4r squared is equal to 2. Negative 5r squared and positive 5r squared cancel. We're going to subtract 16 from both sides, giving us 4r squared is equal to negative 14. Then we can divide both sides by 4, giving us r squared is equal to negative 7 over 2. You can take the square root of both sides, but you should notice fairly quickly that you have an r squared equal to a negative number. So again, there's going to be no real solution. In the future, you will find a way to solve equations that have the square roots of negative numbers, but for right now, again, we just write no real solution.